Let's discuss the numerical in spot welding. So, spot welding is a type of resistance welding, and in this welding, the plates which have to be joined are placed together, normally in an overlapping position, and the workpiece is then clamped. So here you can see this workpiece is clamped with some pressure with the help of some fixture, and the two electrodes are there. Now it is connected through an electrical circuit in which the electrical current passes. Suppose this I, and this I flows for a very short duration of time, and it it is a very of large quantity. Therefore, a heat is produced in this region, because of which uh, this interface melts and a nugget is formed, and this is called the basic mechanism of spot welding. So generally, for the calculation purpose, we assume this nugget as cylindrical in shape. Suppose this is the D is the diameter and H is the height of this nugget. So based on this, we have taken this numerical from the gate examination. So let us read this numerical. Spot welding operation performed on two pieces of steel yielded a nugget with a diameter of 5 mm. So we have the dia D as 5 mm and thickness is 1 mm. The welding time is uh, suppose sorry, let's write this uh, thickness as height h of nugget. Then the welding time we have been given as 0.1 second. The melting energy for the metal. So per meter cube melting energy has been given as 20 joules per mm cube. So we have been given this energy as per mm cube. So we can calculate the total energy for this nugget formation. So this we can easily calculate as total energy. This is per unit volume. So total energy for nugget formation will be given by 20 joules multiplied by volume of nugget. So 20 into pi by 4 d square, this is 5 square, into height. So this is 1. So this will come as 392.5 joule. So this is the total energy required for melting and forming the nugget of given size. Now further we have been given the efficiency of heat conversion at as 10%. So this is 10%, and we have to calculate the power required for performing the spot welding. So easily we can calculate efficiency will be given by total heat required for melting, and this is H is total heat supply. So we have the efficiency as 10%. So this is 0.10 is equals to, see, HM value is 392.5. So total heat required H can be calculated as 392.5 divided by 0.05, sorry, 0.1, 5.0. Therefore, if we calculate this into kilojoules, so it is 393.925 kilojoule. Now, the total time for which it is passed, so total time for which current is passed has been given as, this is the 0.1 second. Therefore, total time given is 0.1 second. Therefore, power required. So power will be given by total energy S divided by time. So this will be 39.25 of kilowatt. So this is the power requirement which is required for the this formation of a spot welding. Now this is again a same problem of resistance spot welding. So in this, let's read this problem. The resistance spot welding of two 1.5 mm thick metal sheet is performed using welding current of 10,000 amps for 0.25 second. The contact resistance at the interface of the metal sheet is 0.0001 ohm. So thickness of plate has been given as 1.55 mm and value of current 10,000 amps, and it is passed for a time 0.25 second. Contact resistance value in ohms 0.001 ohm, and the volume of weld nugget formed after welding is 70 mm cube. So volume V of nugget has been given as 70 mm cube. So these are two plates which are in overlapping position, and this is the nugget formation, typically cylindrical in shape for the calculation. Now considering the heat required to melt, the unit volume is again 12 joule per mm cube. The thermal efficiency we have to calculate. So if this heat per unit volume is 12 joule per mm cube. So total heat for melting can be calculated as 12 into 70. So this is 840 joules. Now total heat produced is I square R into time. So we have the value of I square as 10,000 square into value of resistance R. So R is 10 to the power minus 4, and time is given as for which the current is passes. This is 0.25. So this will come as, after calculation, 2500 joules. Now we have to calculate the efficiency. So efficiency will be given by total heat for melting divided by total heat input. So total heat required for melting is 840 divided by 2500. So after calculation, this will come as 0.336. Therefore, efficiency eta of melting is given by 33.6%. So this is the basic numerical in the spot welding, and it is commonly being asked in the gate examination almost every year.